Commerce Mahavidyalaya, Damangaon Railway. It gives me an immense pleasure to extend to you a very warm welcome on behalf of Other Science, JB Arts and Birla Commerce Mahavidyalaya, Damangaon Railway, who has clubbed all of us for this online guest lecture on the topic Nanoscience and Nanotechnology that is organized by Department of Physics, Adarsh Mahavidyalaya. I welcome Honorable Dr. Y.B. Gandode Sir, Principal, Adarsh Mahavidyalaya. Welcome, sir. I welcome our today's resource person, respected Dr. N.R.Pawar Sir, Assistant Professor and Head of the Department of Physics, Arts, Commerce and Science College, Maregaon, Yavatmal. Welcome, sir.
Thank you, ma'am.
I welcome respected Dr. S.G. Onkar Sir, Head of the Department of Physics, Adarsh Mahavidyalaya. Welcome, sir. Also, I welcome Mr. Thul Sir, Mr. Mende Sir, Dr. Vidade Madam, all the respected faculty members and dear students who have joined with us. I welcome you all. Nanoscience and nanotechnology are the forefront of modern research. Nanoscience and nanotechnology are the study and application of extremely small things and can be used across all the other science fields such as chemistry, biology, physics, material science, and engineering. Nanoscience and nanotechnology involve the ability to see and to control individual atoms and molecules. Everything on the earth is made up of atoms. The food we eat, the clothes we wear, the buildings and the houses we live in, and our own bodies. Nanotechnology is one of the most promising technologies of 21st century. This technology is being used in a range of energy areas to improve the efficiency and cost effectiveness of solar panels, create new kinds of batteries, improve the efficiency of fuel production, and create better lighting systems. Now, according to the protocol of our program, it is the time for introductory speech. So, I would like to request Honorable Dr. S.G. Onkar Sir, Head of the Department of Physics, Adarsh Mahavidyalaya, to deliver introductory speech. Sir, please. Speaker, please.
Hello, Honorable Principal Dr. Y.B. Gandore Sir, Honorable Guest Lecturer, Guest Speaker Dr. N.R.Pawar Sir, Arts and Commerce, Art and Science College, Maregaon, District Yavatmal. My colleagues and all below students, we observed many phenomena in the nature. The working principle of this phenomena is quite complicated one. To understand the working mechanism and beauty of this phenomena, many researchers all over the world are working in that field. So, in order to share their finding and for the recognition of their work by the people, such type of national, international conferences, symposia, and guest lecture are organized all over the world. The country in which the government motivate the researcher for the research work, that country get developed soon, and life of the people become happy. So, such type of motivation to the people in the research field should be there. That should be the program of the country. That country get developed quite well. I am happy here. Today we have with a eminent personality as a guest speaker, that Dr.N.R.Pawar sir. So, without being a barrier between you and Dr.N.R.Pawar sir, I should break my word here. Thank you.
Thank you, sir, for your kind information. Now it is the time for floral welcome. So I would like to request respected Dr. Onkar sir to offer bouquet to Honorable Principal sir.
Thank you. Thank you very much.
Thank you, sir. Now, I may request respected Mr. Thul sir to offer bouquet to Honorable Dr. Onkar sir. Thank you, sir. As the event is online, so we welcome our today's guest, Honorable Dr. Pawar sir, with floral words. Dr. Pawar sir,
Thank you, ma'am.
please
Thank
accept
you,
sir
thank
our
you, thank you,
virtual
thank
floral welcome on behalf of Adarsh Mahavidyalaya. Welcome,
thank you,
sir.
thank you, ma'am.
Nanotechnology is very useful for our society, for our country. From the last few decades, researchers concentrated to do work in the field of nanoscience because of its importance for society. I hope today's lecture may be useful for our students to understand about nanoscience and nanotechnology. Nanotechnology has the huge potential to transform people's life for the better. To throw some more light on nanoscience and nanotechnology, our guest speaker is with us. So without wasting much time, I would like to request Mr. Girish Mende sir to present brief introduction of our today's guest. Over to you, sir.
Good afternoon to one and all.
Sir, you are not audible. Mende sir, you are not audible.
Yes, sir. Okay, good afternoon to one and all. Today, Department of Physics, Adarsha Mahavidyalaya, Ramangaon Railway, organizes guest lecture on nanoscience and nanotechnology. It gives me an immense pleasure to introduce today's guest, Dr. N.R. Dr. N.R. sir, working as Assistant Professor and Head, Department of Physics, Arts, Commerce and Science College, Maregaon Road, District, Yavatmal. He has published 121 research articles in various international and national journals. He has received he delivered 16 invited talks in various international and national conferences and more than 25 guest lectures on various topics for UG and PG students. He has written one textbook and two are in process. He is a renowned guide and 2 students completed their PhD and 3 students are registered under his guidance. He visited 2 times abroad in countries Singapore and Malaysia. He has awarded by Dr. T.K. Saxena Memorial Award in 2015 for the excellent research in the field of ultrasonics and Maharashtra Gaurav Puraskar in 2019 for excellent work in various fields. 7 times he received Best Research Paper Oral Presentation Award. Once again, I welcome Dr. N.R.Pawar, sir. Thank you.
Thank you, sir. Thank you for introduction. Nice introduction.
Welcome, sir.
Thank you, Mehndi sir. Now, I would like to request Dr. Pawar sir to please share your knowledge with us. Please, sir.
Thank you, ma'am. Good afternoon to all. Respected Honorable Dr. Gandole, Principal of the college, Professor Dr. Onkar sir, he is my guru, head Department of Physics, Professor Thul, Dr. Sharma ma'am, and Professor Mende, all teaching and non-teaching faculty of the Department of Physics, dear student, all excellencies, and all. First of all, I would like to thank Professor Dr. Onkar sir for inviting me. Sir is a most senior faculty member not only in Yavatmal district in Amravati University. Really, it's a proud moment for me to deliver a talk in front of such a eminent personality and eminent expert. Thank you, sir. As per the suggestion by the Professor Dr. Onkar sir, I have prepared this topic specially for the BSc student. I trust it will beneficial to research scholar and the PG student also, and those who are pursuing the PhD. Once again, a very good afternoon to all, and I will deliver talk on the topic nanoscience and nanotechnology. These are the contents of my talk. What is the nano word and what is the nanometer? Nanoscale and nanomaterial. Classifications of nanomaterial, nanoscience and nanotechnology. What is the history of nanotechnology? What are the factors cause the properties of nanomaterial? Basically, two factors play a very important role on the properties of the nanomaterial. As we reduce the size of the material, then the surface area of the material goes on increases that play very important role for the enhancement in the properties of the material, and that is the beauty of the nanoscience and the nanotechnology. Then what are the methods for the synthesis of the nanomaterial, especially top down and the bottom up approach in nanotechnology? Then various nanosynthesis method, and especially I am focused on the Sol-Gel method. Then characterization and analysis of nanomaterials. And nanofluid, this is the topic of my research. What is the stability of that nanofluids, applications, conclusions, and the need of the sustainable nanotechnology? What is the nano word and nanometer? Nano word is a highly integrated and extensively broad area of research and development. The two terms used with reference to the nanomaterials are nanoscience and nanotechnology. What is the nanometer? The nanometer is a unit of length in metric system equal to 1 billionth of meter, that is 10 to the power minus 9 meter. It is 10 times smaller than the width of DNA. This is the DNA here. And 10 times larger than the size of an atom. This is atom. Dear student, we conclude from this, atom are in the range of 10 to the power minus 10 meter, that is 0.1 nanometer, less than 10 times of the nanometer. Water molecules are in the range of 1 nanometer, that is in the nano range 1 to 100 nanometer. And DNA are the larger than the nanomaterial 10 times. And what is the quark? It is less than the atom, that is less than 0.1 nanometer. As we know, in 2020, scientists invented that the neutron and the proton can be divisible into smaller part, and that smaller part is called a quark, and its size is less than 10 to the power minus 9 meter, and that is called a quark. And from this we conclude that what is the size of the nanomaterial or nanoparticle? That is the 10 to the power minus 9 meter. Water molecules are in the range of the nanomaterial. Atoms are less than 10 times. DNA molecules are the greater than 10 times. And quark are very, very small as compared to the atom. Nanomaterials are applicable in our daily lives. One of the very famous example, very popular example is that nanomaterials or the nano scale are applicable in our smartphone. These are the processors. Processors are used in our smartphone, and these are the same. The size range of the processors are in between 7 nanometer to 10 nanometer. The 7 nanometer processor are superior to 10 nanometer in the same size. As we reduce the size, the advantages are more. Advancements are more. More nanometer does not mean better. The less the nanometer, the more efficient the processor. Definitely, we select the processor of 7 nanometer in place of the 10 nanometer for advancement. Nowadays, we use this type of SIM, that is a nano SIM. What here? Our standard SIM having the diameter 25 nanometer, 15 nanometer, and the thickness 0.76 nanometer. Our macro SIM diameters are 15 nanometer, 20 nanometer length, and this is the width, and the thickness is a 0.76 nanometer. And what is our nano SIM? Diameters are 12.3 nanometer, 8.8 nanometer, and the thickness 0.67 nanometer. Nanoscale, it is referred to object with dimension of the order of 1 to 100 nanometer. Nanomaterials are nothing but the particles of metal, semiconductor, and insulator with size in the range of 1 to 100 nanometer, at least in one of the 3 dimensions. They broadly divided according to their degree of confinement: 1 dimension nanoparticle, 2 dimensions, 3 dimensions, and 0 dimensions are nothing but the quantum dots. 1 dimensions are nanowires, nanorods, nanotubes. This is the example of carbon nanotube, is the example of 1 dimension. Graphene is the example of 2 dimension. Graphene, nanoplates, nanosphere, and the nanoparticles are the examples of the 3 dimension. For quantum dot, no 1 dimensions are larger than 100 nanometer. No 1 dimensions are larger than 100 nanometer. Nano size comparison, laptop are in the range of 0.1 meter to 1 meter. This is the microchannel are in this range. Bacteria are in the range of 1 micrometer to 10 micrometer. Viruses are in the range of this 10 nanometer to 100 nanometer. And the molecules are in the range of 0.1 nanometer to 1 nanometer. And our nanoparticles are in the range of 1 nanometer to 100 nanometer. If any one of the dimensions of the material are in the range of 1 to 100 nanometer, whether it is a length, whether it is a breadth, whether it is a thickness, then that materials are called the nanomaterials. Classifications of nanomaterial. Nanoparticles are broadly divided into various categories depending on their morphology, size, and chemical properties. Carbon-based nanoparticles, fluorines and carbon nanotubes are the two major classes of carbon-based nanoparticle. Out of these, the carbon-60 having the diameter 7.114 nanometer, and while the fluorine, the diameters are in the range of 7.648 nanometer. Metal nanoparticles are purely made up of metals, and due to well-known localized surface plasmon resonance characteristics, these nanoparticle possesses unique optoelectrical properties. And these are some examples of the metal nanoparticle, because we are familiar with this: carbon, after then copper, silver, and gold nanoparticle. These are the metal nanoparticle. After then lipid-based nanoparticle. These nanoparticles contain lipid moieties and effectively using in many biomedical applications. Generally, these lipid nanoparticles are spherical with diameter ranging from 10 to 1000 nanometer. And polymeric nanoparticle. Lipid nanotechnology is a special field which focuses the designing and synthesis of lipid nanoparticle for various applications, such as the drug carriers and delivery and RNA release in cancer therapy. Then ceramic nanoparticle. Ceramic nanoparticles are inorganic and non-metallic solid and synthesized via heat and the successive cooling. And these nanoparticles are getting great attention of researchers due to their use in and applications in so many fields. Then important, that is the semiconductor nanoparticle. These nanoparticles are generally applicable in electronic devices. Semiconductor nanoparticle possesses wide band gap and therefore shows significant alternation in their properties with band gap tuning. They are very important material in photocatalysis, photo optics, and electronic devices. What is nanoscience? It is an emerging area of science which involves the study of material at nanoscale, having range 1 to 100 nanometer. And the technology based on the nanomaterial, that is called a nanotechnology. Researchers develop and apply material at nanoscale to develop new product or methods, that is turning nanostructure into usable tools and applications, that is nanotechnology. It is also the technology of design, fabrication, and applications of nanostructure material. It is likely to have a profound impact on our economy and society in the early 21st century, because now number of products, number of materials are available based on the nanotechnology, and we use that materials in our daily life. This is the technology in nanotechnology involve the manufacturing and applications of instruments and materials that have unique properties because of their small size. As we know, when we reduce the size of the material, then the number of particles comes on the surface. The surface area to volume ratio increases, and that enhances the properties of the material. And this is the principle of the nanotechnology. Why the enhancement of the properties? Because if we consider the bulk material, when we reduce the size of that material in the nanoscale, then what happens? Chemical reactivity increases, optical property increases, mechanical strength increases, and lot of properties increases because the number of particles comes on the surface area increases. That is the beauty of the nanotechnology. Researchers using these unique properties of material at the small scale to create new and existing tools and products in all areas of science and engineering. Dear student, we conclude these are the nanoparticles because the nanoparticles are very small, are in the range of 1 to 100 nanometer. That nanoparticle applicable in number of products, these are the products, these are the nanowires, and that is nothing but the nanotechnology. By using the nanomaterial, we have synthesized the number of products like this, and these products are applicable in our daily life, in number of appliances. Nanoparticle improve our living standard. We are survive, number of people are survive in a very luxurious society, and that is because of the nanotechnology. The history of the nanotechnology. Nanotechnology is not a new. Professor Feynman is the father of the nanotechnology. He has delivered a talk in 1959 at session of American Physical Society. In this lecture called "There is a lot of space down there," for the first time the possibility to create a nano-sized product with the use of atom building particles was considered. And onward, the number of scientists invent the nanoscience and the nanotechnology in various fields, whether engineering field, medical field, in research field, and like that. The word nanotechnology was introduced first time into scientific word in 1974 in Tokyo by N. Taniguchi. And after then, so many discoveries will be invented by the scientists. And nowadays, we are survived in the world of nanoscience and the nanotechnology. What is again the history? Nanotechnology is not a new. Gold nanoparticle in glass are reflected as a red. These are the gold. And the gold nanoparticle, when you insert in this type of the glass tube, then that should be reflected as a red. Why? Because the optical property of the material changes. And so the yellow color converted into the red color. Because of we reduce the size of that material. In ancient times, stained glass makers know that when we put finely gold or silver in the glass, they would get beautiful colors like that. These are the colors of the gold nanoparticle or silver nanoparticle. They use nano-sized gold and silver particles since optical properties change with the nanoscale, and they design the decorative product like this. So the nanotechnology, the history of the nanotechnology was start from the ancient times, and it's not new. Gold and silver nanoparticle were used as a pigment to attain color in glasses in 17th century. The designer designs this type of the products, decorative materials by using the nanotechnology. These are the two cups. The cup exhibits red color when lit from behind and green when seen in reflected light from the front side. Again, it is the beauty of the nanotechnology. Now, where is the nanotechnology? Nanotechnology is everywhere. These are the products. These products are familiar with us, and in all these, there is a use of the nanotechnology. Principal factors cause the properties of the nanomaterial. Basically, two factors. One is increased relative surface area. Why the enhancement in the properties of the nanomaterial? Because these two factors play very important role for the enhancement in the properties of the nanomaterial. First, increase the relative surface area, and second, quantum confinement effect. These two play very important role for the properties of the nanomaterial as compared to that of bulk material. Again, at nanoscale, the properties of material are very much differ from those at a large scale, and these are high specific surface area. Because we reduce the size of the material, number of particles comes on the surface, and hence definitely there should be the possibility to increase the surface area. High optical band gap, high chemical reactivity, and lower thermal conductivity. Again, these two factors can enhance properties of nanomaterial, and these properties are reactivity, strength, electrical characteristic, mechanical strength, and like that. Now what here, how the surface area increases? we consider these examples. The size effect of nanomaterials. Surface area of this is the L, length, breadth and number of faces. Okay. Now here what is the length? 3. What is the, that is the L is 3, B is also 3 and total surfaces are 1, 2, 3, 4. Then 5 and then 6. Total surfaces are 6. What is the surface area? 54. 3 into 3 into 6, that is 54. Volume of cube is the side cube, that is A cube. And so what here? This volume is a 27. A cube, that is 3 cube and 3 cube is a 27. Surface area upon volume, that is a 54 by 27, that is 2. Now we reduce the size of that. Sides are 2. Then what is surface area? 2, 2 into 6, because the 6 faces also here, 1, 2, 3, 4 and total 6, and that is 24. Volume is a 2 cube and 2 cube is 8, 24 by 8, that is 3. So surface area upon volume ratio is 3. We reduce the size, the ratio of surface area to volume increases. Similarly, again we reduce the surface area, side is 1, then what is surface area? 1, 1 and total faces are also 6 here. For cube there are 6 faces and that is 6. Volume is 1, 1 cube is 1. So surface area upon volume ratio, that is 6 by 1 is 6. And hence we conclude that when we reduce the sides or size of the material, then the surface area to volume goes on increases. Again here, if we consider the spherical nanoparticle, then the surface area upon volume, surface area is 4 pi r square, volume is 4 by 3 pi r cube, and that ratio is 3 by 4. And what is the meaning of that? The surface area to volume ratio is inversely proportional to r, that is the size of the nanoparticle. The surface area to volume ratio increases, then it is inverse relation with the size. This ratio is increases when the size is decreases. Okay, and not the direct relation. Again we consider cube of side 1 meter, then collective surface area is 6 meters square. If we reduce that, the size 0.1 meter, then the collective surface area is 60 meters square. We reduce the size 0.01 meter, that is 0.01 meter, then surface area is 600 meters square. Size is 0.001 meter, surface area is 6000 meters square. Size is 1 nanometer, then what is surface area? We can't imagine, and that is 6000 kilometers square. When 1 meter reduced to 1 nanometer, and there is a collective surface area increases 6000 kilometers square. And this is the beauty of the nano science and the nanotechnology. We reduce the size, then the surface area goes on increases, and definitely surface area to volume ratio increases, and that enhances the properties of the material as compared to that bulk material. One example, dear student, again what here? Cube of side 1 meter, we reduce this size 10 nanometer, then surface area is equivalent to 600 meters square, and that is equivalent to 6 running track having length 100 meter and the width is 1 meter. So if the cube of side 1 meter is reduced to 10 nanometer, then what is the surface area? Surface area is 600 meter. And this is the base of the nanoscience and the nanotechnology. Second important thing is that who is responsible for the nanotechnology, that is the quantum confinement. As the particle size decreases, the electron become more confined in the particle. As a result, valence band, that is the field band, we know very well the valence band, and the second is the conduction band. The valence band, that is the field band, and the conduction band, that is the empty orbitals, break into quantized energy level. And this play very important role in the development of the new devices. This quantum confinement play very important for the development of the new devices. When the atomic orbitals of nanoparticle become discrete or the quantized, quantum confinement occurs. Quantum confinement is the restriction of electron movement. We have restricted that electron movement. And quantum confinement is achieved when the electron remain below the Fermi energy, and that we are familiar with that. And this quantum confinement make it possible to fabricate material with a tunable electrical and the optical properties, and which can result in the development of the new devices. And this is the cause of the nanotechnology. One is the surface area, increase in surface area, and second is the quantum confinement. And there are so many theories related to the quantum confinement. I will not demonstrate here all this theory. And there are so many properties of the nanomaterial that we have discussed earlier also. The mechanical property, that is improve the hardness, magnetic property, increase magnetic coercivity of the material, electrical property, increase electrical conductivity, optical property, that is the spectral shift of optical absorption and the fluorescence property, and again increase quantum efficiency of semiconductor nanocrystal. Catalytic property. Nanomaterials are act as a catalyst to enhance the rate of chemical reaction and vapor decomposition process. And this is the one of the example of the carbon nanoparticle. This is a carbon nanotube. That is a carbon nanoparticle. As we have discussed in introductions, the carbon nanotube is one of the examples of the example of the nanomaterial or the nanoparticle. What here we observe in this moment, the high strength, a very great tensile strength. When we reduce the size of the material, the tensile strength of the carbon nanotube increases. Also, this nanoparticle or the carbon nanotube conduct heat and electricity, and due to that, and again, conduct heat, electricity, and show the great tensile strength. And such type of the materials are applicable in so many fields. We have synthesized the nanoparticles top down and the bottom up approach. What here? These are the very simple concept. Nanoscale objects are made from the larger object. Nanomaterials or the nanoscale materials are synthesized from the large scale object. These are the large objects that can be converted into the nanomaterial or the nanoscale material. That is the top-down approach. And now here the integrated circuit fabrication is the example of this, and lithography is also the another example of this. Second is the bottom-up approach, bottom to top. Means very small particle just like atom and the molecule that can be converted into the nanoscale, and this is one of the approach or the method of synthesis of the nanoparticle. Making larger nanostructure from smaller building block like atoms and the molecule. Now there are again the so many techniques are included in the bottom-up approach. And this is the example of the carbon nanotube. Where the carbon nanotube we have, this is a carbon nanoparticles or simply the graphene that can be converted into the single layer carbon nanotube. This is a multi-layer carbon nanotube and the rolling of this. And all these are because of due to the conduct heat, electricity, and the great tensile strength. This is one of the example. And there are so many nanoparticles. These nanoparticles are applicable in our daily life, and they show the great properties in nanotechnology. Now up to this is a enhancement part and not for the BSc student, but it's my duty to aware the students about the research. There are so many methods for the synthesis of the nanomaterials or the nanoparticle: physical method, chemical method, and the biological method. Physical methods are ball milling, thermal evaporation, lithography, vapor phase, and the chemical methods. Generally, we use this method for the synthesis of the nanomaterial, soil gel processing, co-precipitations, and like that. After the CVD, chemical, vapor decomposition, and like that. And these are some of the biological methods. Okay. Generally, we focus on the chemical method for the synthesis of the nanomaterial, and these are the co-precipitation, soil gel processing, microemulsions, and like that. These are the chemical methods. Dear student, we focus on this. What is the soil gel processing? Sol stand for the solutions and the gel stand for gel, because we know very well the precipitate is nothing but the gel. Solution converted into integrated circuit, that is a precipitate, that is also called a gel, that is called a soil gel processing. This is the solution. This solution can be converted into the gel like this. Very simple technique. Chemical solution converted into an integrated network, that is called a gel. Solution converted into gel, that is the soil gel processing. In this, there are typically, we undergo two processes, two reactions, especially the one is hydrolysis and second is the condensation. This is a hydrolysis reaction and this is the condensation. Here, the metal haloxides and metal chlorides are typically undergo hydrolysis and the polycondensation reaction. Again, what here? Generating metal, oxygen, metal. Now here, metal, oxygen, metal. Silicon is metal, oxygen, and metal, oxygen, metal. Metal, oxygen, metal. Or metal hydroxide metal. Metal hydroxide metal. Here also metal hydroxide metal. Okay, here also metal oxygen metal, metal oxygen metal, or metal hydroxide metal, and like that. Polymers in solution, because that is nothing but the without polymer it is not possible to formation of the gel. Now what here we obtain the metal oxygen metal or the metal hydroxide metal polymer in solution, and after by a drying process the liquid phase we remove and that can be converted into the gel. By drying process we convert that solution into the gel after removal of the liquid phase. Then by thermal treatment, that is called a calcination, we enhance the mechanical properties of the material. And this is a very simple technique for the synthesis of the nanomaterials or the nanoparticle. What here? Very simple process. Now what here? Solution converted into the gel, then it is a dried, after then that converted into the particle size by grinding and then shifting as per our requirement for further study. And this is a sputtering. Okay, I will not explain here because for BSc student. And this is also the second method for the vapor liquid solid technique, that is VLS technique. And we synthesize the TiO2 nanoparticle by using the bottom up technique. What here? Here alizarin and second is the titanium for isopropoxide. This is alizarin and this is okay. We explain with the structure because especially in physics, the structure play very important role because we study the physical interaction and not the chemical interaction. And that can be converted into this alizarin, TiO2, titanium dioxide hybrid structure. This is hybrid structure. What here? Alizarin and the titanium 4 isopropoxide form alizarin titanium dioxide hybrid structure. This is hybrid structure. Then by calcination, that can be converted into thermally converted to graphene titanium dioxide composites. Graphene pair accept photo excited electron from titanium dioxide and slow down charge recombinations, and there is a formation of our nanomaterial. And this is the flowchart of the same. We have synthesized the number of nanoparticle because my two student awarded PhD on the same topic, and we have synthesized the number of nanoparticle by using various technique. We have also synthesized the number of nanoparticle by using the eco-friendly, that is the biological method also. We have synthesized the alpha nanoparticles. Okay, here also the same. What happened? I will not explain here. Nanoparticle of alpha particle was prepared by Soldier method from aluminum isopropoxide and aluminum nitrate, and this solution can be converted into the gel, and after then we dried that, and by cancellation that can be converted into the nanoparticle. This is a synthesis of silicon carbide nanoparticle because this nanoparticle play very important role, and especially in power generation. Bone meat nanoparticle play very important role in the agriculture field. We have synthesized this nanoparticle by using various techniques also. Silver nanoparticle, this is a metal nanoparticle. We have synthesized by using again soldier techniques and by eco-friendly, by using a plant extract also. And what are the characterization? Now, the synthesis of the nanoparticle by various techniques is over. Characterization is very important. Different characterizations techniques have been practiced for the analysis of various physiochemical properties of nanoparticle, and these techniques are X-ray diffraction, that is XRD, X-ray photoelectron spectroscopy, that is called XPS, IR, infrared, SEM, TEM, and BATE, and particle size analysis. And like that, there are so many techniques for the characterization of the nanoparticle. What is the morphological characterization? That is simply the surface study of the nanoparticles. We have synthesized the nanoparticle, and what is the morphology? What is the surface study of that? The morphological features of nanoparticle always attain great interest since morphology always influences most of the properties of the nanoparticle. There are different characterizations technique for morphological studies, but microscopic techniques such as the polarized optical microscopy, same time, are the most important of these. Again, same technique is based on the electron scanning principle, and we will explain in detail in next slide also. The structural characteristics are of the primary importance to study the composition and nature of bonding material. It provides diverse information about the bulk properties of the subject materials. Again, the XRD is one of the most important characterization technique to reveal the structural properties of the nanoparticle. Okay, and TEM device is widely used to about the elemental composition with rough idea of the percentage, because for BSc student I will not explain in detail. Okay, and like that. Now, especially for BSc student, what is the morphological characterization? Just here we have discussed what is the same. From the same, we learn the surface morphology. After then the particle size, and second is the shape of that. Then what is the term? We understand the internal structure. Now, observe here. We observe the internal structure by using the term. Again, second is the particle size, and next is the crystal or the atomic structure. We understand the atomic structure by using the term. I think this is the hexagonal, and like that. Then EDS is one of the technique. It is used to determine the elemental composition of nanoparticle. What are the composition? What are the elemental composition of nanoparticle? And by using this technique, we can understand that. And then FTIR also play a very important role because vibrational characterization of nanoparticle is normally studied via FTIR. Again, SERS also, surface enhanced Raman spectroscopy, is involving as a vibrational conformational tool due to its single enhanced capability via SPR phenomena. And again, then AFM and like that, these are the so many technologies for the characterization of the nanomaterial. Large surface area of materials offer great room for various applications, and BET is the best technique to determine the surface area of nanomaterial. This technique is based on absorption and deabsorption principle and Bate theorem, because Bate theorem is a base for the Bate technology. Again, then, so this is the ultraviolet visible, that is UV visible, photoluminescence, and like that. Then DRS, these are the so many techniques for the characterizations of the nanoparticles. Now, these are the techniques for the characterization of the nanoparticles, and now what are the analysis of that techniques or the analysis of the nanomaterial. Now, here we discuss about the XRD, Raman spectroscopy, UV visibles, then same time, and the atomic force microscopy, that is AFM. Spectroscopy based techniques such as XRD, Raman, and UV visible techniques are considered as an indirect method. Same time and AFM are the direct method for determining surface morphology, crystalline size, and surface topography of the nanomaterial. From the XRD, we learn the grain size, thickness, crystalline phase. From Raman spectroscopy, we learn about the composition and interaction between the molecules, and is visible to determine band gap using absorption spectra. This is a X-ray diffractometer, and using that we find the grain size of the nanomaterial by using this formula. This formula is called the Scherer formula. 0.9 lambda, that is the wavelength of that is also given here. B cos theta, this is the thickness, and this is the theta is the angle of diffraction. What is XRD? It is a non-destructive technique used to analyze the structure of the crystalline material. It is the way of the study of the crystal structure is used to identify the crystalline phases present in the material and thereby reveal chemical composition of the information. Generally, we study the XRD pattern of the number of nanoparticles. And now what here? This is the XRD pattern of single crystal specimen. These are the single crystal specimen, and the XRD pattern of these specimens are like this. Scattering angle, and this is the scattered intensity that is obtained from X-ray diffractometer. This is the general XRD pattern of the liquid specimen. If we find the XRD pattern of the liquid specimen, then the XRD pattern is like this. This is the XRD pattern of the gas molecule. And now the XRD pattern. From that we can find the width, that is a B. This is a maxima, and the half of that maximum, that is a B, that is already available in our formula, Scherer formula. And that B equal to what? That B is half of 2 theta 1, this 2 theta 1 minus 2 theta 2. 2 get cancelled, then theta 1 minus theta 2. And that is nothing but the B. And that is already available in our data. What here? This is the XRD pattern of my alpha alumina. We have synthesized the alpha alumina. And this alpha alumina compare with the standard data. These are the standard data. XRD pattern of alpha alumina nanoparticle compare with the JCPDS file number 711127, and these two are exactly close with each other, and hence these two are in good agreement. So our synthesized nanoparticle is good for the research. When we synthesize any nanoparticle, then we conclude that nanoparticle is a perfect for the further study, for the characterization, for the analysis. We compare that with the standard data. And like that, It is seen that the alpha alumina nanoparticle is well crystalline nature, and the estimated size of alpha alumina nanoparticle by Scherer formula is found about 20 to 30 nanometer. Similarly, this is a Boeing-Mint nanoparticle. This is a very important nanoparticle that is also in good agreement with the standard data, like that this is silicon carbide and like that. Just here we have discussed here what? This is the position 2 theta. We have discussed, we find the B. For B, we consider this is this position because this is the maximum peak. Intensity is 100. And this is a 2 theta. After then, this is the height. And from that, we can find B. Because here, at this position 35, we obtain the maximum peak. And from this, we find this is, we consider this peak. And this B equal to half width that we find in previous slide. Crystallographic refinement software is available. We insert all these available data in that, and we can easily find the lattice parameter, interfacial angle, lattice constant, and phase may be identified from this data. This is a technique used to obtain an infrared spectrum of absorption or emission of the nanomaterial. Here again, I will not explain in detail. This is a FTIR spectra of the Boeing-Mint nanoparticle. It is also in good agreement with the available data. These are the same images of the alpha alumina nanoparticle. These are the foam-like structures. I will not explain in detail because the level is high of this. This is a specially applicable. This is a specially useful for the research scholar and those students who are pursuing the PhD and also for the PG student. Okay, these are the same images, and what is the same? It is a technique that produces images of a sample by scanning the surface with a focus beam of electron. The electron directly interact with the atom in the sample, producing various signals that contain information about the topography. And other characterization, then TAME that we have discussed, particle size. TAME is applicable for the particle size confirmation. EDS that also we have discussed. It is applicable for the elemental analysis. And this is the setup. These are the X-ray diffractometer of standard quality. And this is the Raman spectroscopy. This is the same. After then, F is same. It has a high resolving power as compared to this. Then this is a spectrophotometer. And this is the TAME. And like that. And in my study, I will not explain in detail. We use the two-step method for the synthesis of the nanoparticle because why we use the two-step method? Because there are so many drawbacks for the synthesis of the nanofluid by one-step method. In one-step method, we have used the ready-made particles available in the market, and these particles are dispersed in the base fluid like methanol, ethanol, or the acetone, and that can be converted into the nanofluid by using the magnetic stirrer or the ultrasonication. But basically, in my research, we use the two-step method for the synthesis of the nanomaterial because we have synthesized the number of nanomaterials by using so many techniques, and these nanomaterials are then dispersed in base fluid, whether it is a methanol, whether it is a ethanol, by magnetic stirrer or by the ultrasonication. Then finally the mixture is subjected to microwave heating till the reaction completes and the color of the mixture may change. The often product is the nanofluid in my case. Now what here? Two-step method. We disperse the nanomaterial in the base fluid in order to obtain the stability of the nanoparticle in the base fluid. We use the ultrasonications or the magnetic stirrer method. And these are the same images of the nanofluid. What here? We have synthesized the nanoparticle. these nanoparticles are dispersed in the base fluid. We obtain the nanofluid by the ultrasonications or the so many techniques by using that. Okay. In order to obtain the stability of the nanofluid. Now, the same images are completely different than the same images of the alpha alumina nanoparticle, and hence we conclude that the nanofluid is excellent for the study. What here? Same images show the good dispersion of Boehm nanoparticle in base fluid. It is important for the qualitative analysis. These are also the same images of alpha alumina, and these are the same images of the Boehm nanofluid. And again, we conclude the size of that nanofluid by using the thermoacoustical study. By using the pulsar issuer method, we find the some basic parameters, and from that we compute the number of thermoacoustic parameters, and by inserting all these parameters in this standard formulae, we compute the RO, that is intermolecular radius, and that is nothing but the size of that nanofluid. Okay, that is available in the medium. And definite the size of this either differ than the size of the nanoparticle, and hence we conclude that it is better for the study. And for the stability of the nanofluid, the Brown motion play very important role, because it is the erratic random motion of nanoparticle in a fluid as continuous bombardment from the molecule of the surrounding medium. And this play very important role in order to obtain the stability of the nanofluid. And for the stability of the nanofluid, zeta potential play very important role, because it is the potential difference across the phase boundaries between the solid and the liquid. It is a measure of the electrical charge of particles that are suspended in liquid. It is a measure the stability of the dispersion form due to the reaction. And this is my study, zeta potential of silicon carbide. And the thermal conductivity play very important role, because the thermal conductivity of the nanoparticle play a very important role. Nowadays, we use the traditional coolant. It is made up of copper and the water. As we know very well, it is green in color because of due to the copper. If we replace that coolant with the nanofluids like alpha alumina, we have synthesized the number of nanofluids. One is a ferrofluid. It is an excellent nanofluid. We replace that in place of the traditional coolant. Definite, we increase the durability of the machines like our vehicle. We increase the mileage of our vehicle. We reduce the size of the flight. So this is a very important topic for the research nanofluids, and especially in power generations, and especially in the automobile sector, and especially in because in number of industries we use the large number of devices, large number of instruments, large number of machines, and all these are run on the coolant. If we replace that by the nanocoolant, definite we develop a new technology, and that is based on the nanofluid. And now what here, there is a strong, that is also that we have discussed, and I will not take much time. And this is a stability of the nanofluid. We study the number of thermoacoustic parameters by using the pulsar receiver. And again, so many instruments are available. And these are the applications of the nanoparticle, because the nano size inorganic particles of either simple or complex nature display unique physical and chemical properties that we have discussed in earlier, and represents an increasingly important material in the development of novel nano devices, which can be used in numerous physical, biological, biomedical, and pharmaceutical applications. Also, these nanoparticles have drawn increasing interest from every branch of medicine for their ability to deliver drugs in the optimum dosage range, often resulting in increased therapeutic efficiency of the drugs, weaken side effect, and improve patient complaints. And like that, there are so many applications of the nanoparticles and the nanomaterials. And then this is a nano coated mask, okay? And definite, This nano-coated mask protect to everyone from the COVID-19. Again, this is one of the excellent applications of the nanomaterials and nanotechnology. Reticuloendothelial system cleanage, and this nanoparticle nanomaterial cleanage our system. And these are the conclusions, and especially related to the nanofluids, because enhancement in thermal conductivity of the nanofluid is due to the stability of the nanoparticle in nanofluid. Because the stability of the nanoparticle in nanofluid is very important, because without stability, the nanofluid is not ideal for the research. And we study the stability just that we have discussed, especially by recording the zeta potential, and after then so many parameters. And nanofluids have high thermal conductivities and heat transfer coefficient compared to those of the conventional fluid that we have discussed, and especially I am talking about the coolant. Nanofluid properties make them suitable for the next generation to flow and heat transfer fluid. Pioneering nanofluid research has inspired physicists, chemists, and the engineers around the world. This is the future work, okay? And the sustainable nanotechnology, okay? What is the sustainable nanotechnology? We have synthesized the number of nanoparticle. We have developed the technology, nanotechnology on the base of the nanomaterial. Then what is the future of that? It may cause the dangerous effect on the society. It may cause the dangerous effect on the environment. Then what is the future of that? And for that, the sustainable nanotechnology important. What here? The material processing, we have synthesized the nanomaterial manufacturing. After then, what is the use of that? And what is the end of life of that material? So every researcher, it is a challenge. We have synthesized the material, then what is the end of that material? Before synthesizing such type of material, definite researcher may think about this sustainable nanotechnology, and especially for student innovations and the motivation for research. What is innovation? अब मैं यहाँ पे थोड़ा सा हिंदी में बात करूंगा, फॉर स्पेशली फॉर स्टूडेंट. इनोवेशंस क्या होता है? जो नई चीज होती है उसमें से हम लोगों को थोड़ा नावेल रिसर्च निकालना है. We are the familiar with this restaurant, we are familiar with the traffic road, we are familiar with the classroom, we are familiar with the DJ. The noise produced here in restaurant 50 dB, by traffic road 75 dB, classroom 35 dB, and DJ 100 dB. And on the airport 90 dB. कभी आप सपोज फ्लाइट से आप ये कर रहे हो, ट्रैवलिंग कर रहे हो, तो फ्लाइट्स कि आप अंदर जब जाते हो तो वहां पे देखना आपको ट्रैवल से लेके जाते हैं, बिकॉज कि वहां का नॉइज बहुत ज्यादा होता है और आपके जो है मतलब आपकी कंप्लीट हेल्थ उससे डैमेज हो जाता है, आपका हियरिंग इफेक्ट कंप्लीट खत्म हो जाता है. एंड फॉर दैट हम लोग ट्रैवल्स वो ले जाते हैं. बहुत बार लोग उनको बेवकूफ भी कहते हैं, एंड इट इज अ लैक ऑफ अवर नॉलेज. What is the noise pollution? If noise level is of 90 dB of continuous period can cause the loss of hearing. And this type of noise is available in airport, especially inside of the airport. Average noise level has been found to be between 65 to 90 dB. The noise level to double its present value every 6 years. Noise level above 50 dB cause कार्डियोवास्कुलर प्रॉब्लम. देखो ये नॉइस पोल्यूशन कितना डेंजर होता है हमारे लिए. तो हम लोगों को इससे क्या करना है? वी मे सिंथेसाइज द इको फ्रेंडली अकॉस्टिक मटेरियल. अब अकॉस्टिक मटेरियल क्या होता है? अकॉस्टिक मटेरियल क्या होता है कि साउंड को थोड़ा सा वो प्रोटेक्ट करता है, नॉइस को प्रोटेक्ट करता है. जैसे फ्लाइट में होता है, बाहर का नॉइस अंदर नहीं आता है. दिस टाइप ऑफ मटेरियल्स आर द अकॉस्टिक मटेरियल. और फॉरेन में क्या होता है, जब कोई भी अपना घर बनाता है तो पहले अकॉस्टिक का वो सोचता है. कोई अपना बड़ा ये मंगल कार्यालय जैसे होता है, ओके, थिएटर्स होते हैं, वहां अंदर का साउंड बाहर नहीं आना चाहिए, नॉइज. एंड अकॉस्टिकली डिजाइन ऑल दिस थिंग्स स्पेशली इन अब्रॉड. हमारे इंडिया में ऐसा नहीं होता है. हम तो ओपनली डीजे बजाते हैं और हमारा कान अपने आप हम खत्म कर देते हैं। ओके, सो क्लासरूम में भी आपको देखना है कि क्लासरूम का ये जब हमारे टीचर लोग पढ़ाते हैं तो नॉइस इतना होता है। टीचर नहीं होते तो डेफिनेट दिस नॉइस, ओके, डीबी विल बी 75. Then what happened? Definite it directly affect on our complete health. And we can stop this noise pollution by using nanotechnology, or by using the eco-friendly technology. We have synthesized the acoustic material by using eco-friend material that available in the in our environment. Okay, I will not take much time. These are the top polluted cities, एयर पोल्यूशन। इसमें हमारा इंडिया भी आता है। इंडिया के बहुत सारे आपको मेट्रो सिटीज दिखेंगे। अभी तो आपने देखा होगा कि दिल्ली में तो इतना पोल्यूशन बढ़ गया था कि सोचो मत। एयर पोल्यूशन से खतरे की घंटी देखो 300% एयर पोल्यूशन बढ़ गया है। ये 2013 का रिपोर्ट है। आफ्टर देन 4 साल में 300% पोल्यूशन बढ़ गया है। अभी दिल्ली का मैंने फोटो निकाला है। व्हेन आई विजिटेड टू दिल्ली फॉर डिलीवरिंग अ गेस्ट लेक्चर, देन व्हाट, दिल्ली की हवा में कैंसर पैदा करने वाली खतरनाक धातु ग्रीन पीस है। और सेकंड NiO2 है, जो NiO2 बहुत डेंजर होता है। अभी ये कोविड जब हमारा लॉकडाउन था तो ये लेवल बहुत कम हो गई थी। ये सभी रोम है, मैड्रिड है, न्यूयॉर्क है और हमारा दिल्ली है, वहां का एक फोटो है। बाद में ये पोल्यूशन तो देखो आप, इसमें हम लोग सर्वाइव नहीं कर पाते। Can we stop this pollution by using nanotechnology? 100% we stop this pollution by using the nanotechnology. इसलिए मैं आप लोगों को बोल रहा है कि हमारे सराउंडिंग में क्या पोजीशन है। कोई साइंटिफिक रिएक्शंस हो रही है, we observe that reaction, we observe that physical process, why this process is happen, and study that process. Definite आप उसमें अच्छा रिसर्च कर सकते हैं। बहुत सिंपल चीजें ऐसी होती है, हम लोगों को बहुत अच्छा रिसर्च देती है। इफ वी डोंट स्टॉप द एयर पोल्यूशन, देन डेफिनेट इन 2040 to 2060 it is essential to put on your own oxygen mask like this. अभी हम तो कोविड से बचने के लिए मास्क लगा रहे हैं, लेकिन फ्यूचर में ये पोल्यूशन ऐसा ही चलेगा। मैं वनी में रहता हूं, वनी में तो बहुत ज्यादा पोल्यूशन है। तो हम लोगों को नॉट ओनली फॉर मी एंड अवर चाइल्ड, इट इज इसेंशियल टू अवर एनिमल ऑल्सो। जो हमारे एनिमल्स हैं, हमारे जो घर में हम पालते हैं, उनको भी ये मास्क की जरूरत लगेगी। सेकंड इज लाइट पोल्यूशन। ये हमारा ट्रेडिशनल लैंप है। देखो मैं आपको वेरी बेसिक चीजें बता रहा हूं। BSc लेवल के स्टूडेंट हैं आप, ये सब चीजें आपको मैं थोड़ा सा मोटिवेट कर रहा हूं। सर आप इतने बड़े रिसर्चर हैं, प्रोफेसर डॉक्टर ओमकार सर इज माय गुरु, उनके सामने आपको ये बताना मुझे ठीक नहीं लग रहा, लेकिन कैसा है, इट्स माय ड्यूटी। उन्होंने मुझे ड्यूटी दिया है तो मैं आप लोगों को मोटिवेट करूंगा। एंड इट्स डायरेक्टली सजेशंस बाय प्रोफेसर डॉक्टर ओमकार सर। ओके, ये हमारा ट्रेडिशनल लैंप है, ये आपको लाइट देता है। इसमें लाइट हीट भी होता है। ड्यूरिंग द हीटिंग प्रोसेस देयर शुड बी द फॉर्मेशन ऑफ द कार्बन डाइऑक्साइड। कार्बन डाइऑक्साइड भी हो सकता है यहाँ पे। डेफिनेट इट इज मतलब ये पोल्यूटेंट है, इट इज नॉट इको फ्रेंडली। अब यहाँ पे हम यदि ट्यूबलाइट यूज करेंगे तो ट्यूबलाइट में मर्क्यूरी होता है। दैट मर्क्यूरी इज ऑल्सो हार्मफुल टू एवरीवन। वी कांट डिस्ट्रॉय द मर्क्यूरी। मर्क्यूरी को हम लोग डिस्ट्रॉय नहीं कर सकते हैं। सेकंड जो हमारा CFL है, कंपोज CFL, आपको पता है, कंपोज फ्लोरोल्यूमिनेसेंस लैंप। देयर इज अ मर्क्यूरी ऑफ 4 मिलीग्राम। इसमें भी 4 मिलीग्राम का मर्क्यूरी होता है। इट इमिट्स द अल्ट्रावायलेट रेडिएशंस दैट आल्सो कॉज द डेंजरस इफेक्ट ऑन योर हेल्थ। ये अल्ट्रावायलेट रेडिएशन इमिट करता है। सो वी रिप्लेस द ट्रेडिशनल एंड द CFL लैंप बाय योर LED. It is eco-friendly. वी कंज्यूम ईयर 75% इलेक्ट्रिसिटी। यदि ये ट्रेडिशनल से हम ये यूज करेंगे तो हमारी 75% इलेक्ट्रिसिटी हम सेव कर सकते हैं। पूरे वर्ल्ड में अबाउट 40% इलेक्ट्रिसिटी लाइट में जाती है, हमारे इंडिया में तो बहुत ज्यादा जाती है। सो हम लोगों को क्या करना है, वी रिप्लेस दिस एलईडी। इट इज इको फ्रेंडली बिकॉज ये दोनों भी क्या है, ये पोल्यूटेंट है, हमारे इन्वायरमेंट को पोल्यूटेंट करते हैं, लेकिन ये हमारे इन्वायरमेंट को पोल्यूट नहीं करता है। इसका लाइफ भी ज्यादा है, ये इसका पोल्यूशन भी कम है बिकॉज ये हीट नहीं होता, फर्स्ट थिंग। ओके, एंड एलईडी कंटेन इलेक्ट्रॉन दैट रिकम्बाइंस विद द इलेक्ट्रॉन होल रिलीजिंग एनर्जी इन द फॉर्म ऑफ फोटोन। अब देखो, जो एनर्जी आपको मिल रही है, द एनर्जी ऑफ्टेन और द रेडिएशंस ऑफ्टेन बाय द एलईडी कंटेन्स द फोटोन। अब फोटोन कहां पे होता है आप लोगों को पता है, फोटॉन्स आर अवेलेबल इन द सनलाइट एंड देयर इज अ नंबर ऑफ फोटॉन्स, ग्रुप ऑफ फोटॉन दैट इज कॉल्ड एनर्जी क्वांटा, उसको हम एनर्जी क्वांटा बोलते हैं। So the LED, there is a photon is available in the LED light, so that is eco-friendly. And so I request to everyone, we replace your traditional lights by LED and go eco-friendly and protect yourself, your family, our society and the environment. So what here? LEDs go green. Go green with LED because it is eco-friendly and protect to your environment. There are so many various types of the LED in different shapes are available in the markets, and we may purchase that LED. And we also, it is our responsibility to aware our society about the LED. सोसाइटी को भी आपको अवेयर करना है। आप स्टूडेंट एक प्रोजेक्ट भी आप ये आपके धामनगांव में ये कर सकते हैं कि आप मतलब जो सोसाइटी है जिनको अवेयरनेस नहीं, उनको आप एक प्रोग्राम लॉन्च कर सकते हैं, अवेयरनेस अबाउट द LED। अब मैंने यहाँ पे आप लोगों को बताया कि यहां से देखो, हम एलईडी यूज करेंगे तो 85% हम इलेक्ट्रिसिटी कंज्यूम कर सकते हैं ना। इससे थोड़ा हम आगे जाएंगे, आपको 100% सपोज कंज्यूम करना है तो दीज आर द वॉल एलईडी। नाउ अ डे द बैटरीज आर अवेलेबल इन द मार्केट्स एंड द एलईडी आर ग्रोन ऑन दी बेसिस ऑफ दिस बैटरी। 12 बैटरी ले लो, आपके पूरे दीवार में एलईडी लगा लो, इलेक्ट्रिसिटी की आपको जरूरत नहीं है। एंड दीज आर द वॉल एलईडी, so we can consume our electricity by using the LED light, and so go eco-friendly, go with LED light and protect to our world। अभी बहुत सिंपल एग्जांपल है, मैंने देखो टेक्नोलॉजी इन वॉशिंग मशीन एंड टीवी। ये एलजी का वॉशिंग मशीन है, ये वर्लपूल का है, सैमसंग का है। वी आर मोस्ट फैमिलियर विथ ऑल दीज अप्लायंसेस। अब मैंने यहाँ पे क्यों यहाँ पे ये किया है, ये एलजी है, ये वर्लपूल है, सैमसंग। इसमें भी आपको ड्रम मिलेगा, ये मतलब आपको पता है टॉप का रहता है, फ्रंट का रहता है, इसमें भी ड्रम है और इसमें भी ड्रम है। लेकिन वर्लपूल में जो भी ड्रम है उसमें आपको ऐसे 3 रॉड दिखेंगे। जो नया वर्लपूल आप वॉशिंग मशीन लोगे ऑटोमेटेड, उसमें आपको 3 रॉड मिलेंगे। तो रॉड क्या करते हैं, ऐसे कपड़े को प्रेस करते हैं। आप लोगों ने देखा होगा विलेज में हमारी माँ है, हमारी बहन है, फीमेल है, कोई भी हमारी रिस्पेक्टेड लेडी है, इस स्टोन पर अपने कपड़े धोती है ऐसे घस घस के। वर्लपूल डेवलप दैट टेक्नोलॉजी बाय ऑब्जर्विंग दैट प्रोसेस, दैट रिएक्शन। एक महिला कपड़े धो रही है, उसको ऑब्जर्व करके वर्लपूल ने अपनी टेक्नोलॉजी डेवलप की है। ऐसे रॉड 3 रॉड बिठा दिए, दैट टेक्नोलॉजी डेवलप बाय द वर्लपूल। और अब इसने क्या किया, इसमें अपना पेटेंट फाइल कर दिया। आप पेटेंट फाइल करने के बाद दुनिया में कोई भी वॉशिंग मशीन ऐसे रॉड वर्लपूल जैसे नहीं डाल सकती है। दिस इज द एडवांसेस ऑफ द रिसर्च। रिसर्च कहां पे, हमारे डेली लाइफ में आपको रिसर्च मिलेगा। सेकंड, देयर आर लॉट ऑफ एडवांसमेंट, देयर आर लॉट ऑफ, हमारे मतलब रिसर्च में इतना हम लोगों को एडवांस मिलता है। एट द एज ऑफ 35 ईयर यदि आपकी रिसर्च की क्वालिटी अच्छी है तो आप पूरा वर्ल्ड घूम सकते हैं। मैं भी 2-4 कंट्री गया, मुझे पैसे नहीं लगे, मैंने डीएससी, डीएससीए, सीएसआर है, आफ्टर देन हमारी यूजीसी अप्लाई किया, पैसे मिल गए, मैंने मतलब कॉन्फ्रेंस में जाके अपना प्रेजेंटेशन दे के आया। अब मैं आपको बताता हूं कि ये सब आपको टेक्नोलॉजी तो डेवलप करना है, लेकिन हम जो हैं, हम ह्यूमन बीइंग है, हमारी मैनर आप देखो, ओंकार सर इतने हमारे लिए रिस्पेक्टिव हैं कि पूछो मत। सोसाइटी में आइडियलिटी भी बहुत इंपॉर्टेंट होती है, उसको बोलते हैं हमारा एक स्टेटस होता है। सोनी है, सैमसंग है, वीडियोकॉन है, तीनों टीवी मैंने यहाँ पे लगा दिया। आप बोल रहे होंगे सर ने क्या दिखा दिया यहाँ पे? अंदर का टेक्नोलॉजी सेम है, कंपोनेंट भी सेम है, उसको बोलते हैं कॉन्ट्रैक्ट्स, रेशियो भी सेम है सबका, लेकिन प्राइस डिफरेंस है। सोनी की ज्यादा है 10,000, इसका थोड़ा सा कम है, इससे उससे कम है। वाई? बिकॉज सोनी का एक रेपुटेशन है। तो सोसाइटी में हम कितने भी टैलेंट है, तो हमारा रेपुटेशन, हमारे आइडियल कैरेक्टरिस्टिक्स भी इंपॉर्टेंट है। सेकंड थिंग इज दैट हमारी जो पुरानी वाली टीवी थी, जो हमारा पुराना जो था, ओल्ड इज गोल्ड, उसको आप रिपेयर करेंगे 700 रुपए में रिपेयर हो जाएगा। इसको आप सोनी को आप 1,10,000 का एलईडी लिया है, उसको रिपेयर करो, आपको 55-60,000 लग जाएंगे। इसमें आप थोड़ा सा ऐसा प्रेस कर दो थंब से, तो पूरा स्क्रीन खत्म हो जाएगा। ये ऐसा क्यों होता है? दैट इज ऑल्सो द टेक्नोलॉजी। तो टेक्नोलॉजी के कुछ ड्रॉबैक्स भी हैं, कुछ एडवांसमेंट भी हैं, उसमें भी आप मतलब सर्च कर सकते हैं, उसमें भी आप ये कर सकते हैं। दीज आर द नंबर ऑफ द कैपेसिटर्स, ये हमारे कैपेसिटर्स है। इसमें से कुछ मिलिट्री एप्लीकेशन है एंड कुछ सैटेलाइट में एप्लीकेबल होते हैं। आपको पता है सैटेलाइट्स क्या होता है? एज वी गो अबव द सरफेस, आपको पता है जैसे जैसे हम ऊपर जाते हैं, देयर इज अ वेरिएशन इन द acceleration due to gravity, temperature and up to the density. डेंसिटी वेरिएशंस होता है, टेम्परेचर वेरिएशंस होता है, बहुत ज्यादा वेरिएशंस है, ये आप लोगों को पता है। सैटेलाइट के हम लोगों को ऐसा मटेरियल चाहिए, the density of the material should be remain constant at various temperature. It is impossible. मटेरियल का डेंसिटी कांस्टेंट रहना चाहिए, टेम्परेचर वेरी हो रहा है, ऐसे मटेरियल हम सैटेलाइट में यूज करते हैं, बिकॉज सैटेलाइट वेरियस फेजेस में ऊपर जाता है। वी परचेस दिस टाइप ऑफ मटेरियल फ्रॉम द जापान। ग्रेड 3 मटेरियल, आपको पता है, ग्रेड 1, ग्रेड 2 एंड ग्रेड 3, बहुत बकवास मटेरियल हम परचेस करते हैं, एंड दैट मटेरियल वी यूज इन अ सैटेलाइट। हम लोगों को ये सोचना है, कैन वी सिंथेसाइज सच टाइप ऑफ मटेरियल बाय डेवलपिंग न्यू टेक्नोलॉजी। हम लोग उसको भी मतलब वो एक नया टेक्नोलॉजी है, मैं आपको यहाँ पे नहीं बताऊंगा। दिस इज द ब्यूटी ऑफ टेक्नोलॉजी, दिस इज द ब्यूटी ऑफ द रिसर्च। एंड नैनो पोल्यूशन, मैंने आप लोगों को बताया है कि ये क्या होता है, मैं तो बहुत बता रहा हूं आप लोगों, नैनो साइंस, नैनो टेक्नोलॉजी, बट एवरी टेक्नोलॉजी देयर हैव सम ड्रॉबैक्स। व्हाट इज द नैनो पोल्यूशंस? We have synthesized the number of nanoparticles, and the word is also invented the number of new nanoparticles and invented the new technology. But if we not stop such type of the pollutions, definite we will suffer the number of major disease. Some of the nanoparticle, mostly carbon compounds, enter into the body called damage of blood vessels. That nanoparticle contracts our blood vessel. अब मुझे बीपी नहीं है, मुझे शुगर नहीं है, फिर भी मुझे अटैक आ गया क्योंकि मेरी ब्लड वेसल कॉन्ट्रैक्ट हो गई है। I am specially talking about the Vani and the Chandrapur. There are so many nanoparticles in the air. Environment में भी already nanoparticle हैं। 90% carbon nanoparticles are mostly available in the coal pollution. जो coal mines का जो आपको डस्ट दिखता है, उसमें nanoparticle है, carbon nanoparticle. When these nanoparticles enter in our body, then they may cause the damage of our blood vessel, because they contract the blood vessels, and that directly related with the heart attack. When nanoparticles get into the body, they accumulate in the fatty plaque, causing heart attack and strokes. Gold nanoparticle forms contraction of blood vessel. देखो गोल्ड नैनो पार्टिकल भी डेंजर है। अब सिल्वर नैनो पार्टिकल क्या करता है? व्हेन इनकाउंटर्ड इन द सॉइल इट कैन किल द बेनिफिशियल बैक्टीरिया। हमने सिल्वर नैनो पार्टिकल कहीं डाल दिए तो क्या करता है? हमारे सॉइल में जो भी बेनिफिशियल बैक्टीरिया उसको खत्म करता है। Why? Because the nanoparticle can have the same dimension as biological molecules such as the protein. Peoples are unknown from all type of the nanoparticle because the nanoparticles are available in number of nanowaste. So the awareness is essential regarding to the nano pollution, air pollution, light pollution, and noise pollution. Because we can't protect all these things, then definitely we will suffer from the major disease in future. Most of the human-made nanoparticles do not appear in the nature. अब nano 10 to the power minus 9 मीटर वो दिखते भी नहीं है तो कैसे उसको ये करेंगे? So the precautions is essential for while synthesis of the nanoparticle. Abroad, I am specially talking about the US. US government spent 710 million in 2002 on nanotechnology research and 5 lakh was spent on environmental effect assessment and specially to stop the nano pollution. देखो यूएस कहाँ है? we never think about the nano pollution. अभी तक हमने तो एयर नॉइस और जो सॉइल पोल्यूशन के बारे में भी थिंक नहीं किया, लेकिन यूएस अभी से नैनो पोल्यूशन को स्टॉप कर रहा है। बजट में भी उनका पोल्यूशन के लिए ये अमाउंट रहता है। So the careful planning of new research is required to establish the true impact of nanoparticles on the environment. And this is my laboratory. This is our department. This is my research lab. This is the furnace, and this is a very new instrument for the measurement of the thermal conductivity, because I have already demonstrated the importance of the thermal conductivity, because the thermal conductivity play a very important role for the nano fluid and the traditional fluid. This is the magnetic stirrer. After the balance and the pH meter, these are the crucibles and centrifuge, and again there are so many instruments are available in my laboratory, and I am very much thankful to our parent management and the principal for providing such a excellent facility in my laboratory for research. These are the memories, not is important here, and on the innovative work. मैंने आप लोगों को बताया कि हमारा वर्क कैसा होना चाहिए, हमारे सराउंडिंग में क्या है. My work is a research work is going on the resources available in our premises. हमारे वनी में, हमारे मारेगांव में क्या मतलब नेचुरल रिसोर्सेस है, उस पर मेरा एक मतलब अच्छा काम चल रहा है. इसका कॉन्फिडेंस में मतलब इसका जो कॉन्फिडेंशियल में यहाँ पे ओपन नहीं करूंगा, लेकिन फ्यूचर में if you are interested then definitely you contact with me. And these two very great persons awarded PhD under my supervision. Professor Dr. P.D. Bageshwar is a professor in the Department of Physics, MM College, Mungsaji Maharaj Mahavidyalaya, Dharwad. And second is again, he is a registrar in a Government Agriculture College, Maharaj Bagh, Nagpur. And 3 students are working under my supervision. And these are the references, and specially acknowledged to honorable respected my guru, Professor Dr. H.G. Onkar sir, a professor and the Department of Physics of the same college, and Professor Viestul. I also acknowledge to Sarma ma'am, Mende sir, and all faculties of Department of Physics, teaching, non-teaching staff, and the principal and the management. And thank you for your kind attention. This is my mobile number and the email ID. Dear student, for any queries, you may ask your queries or you may share. You may put your queries, you may post your queries in the chat box, or you may also mail directly to your queries. तुम्ही मराठीत मला विचारलं तरी चालेल, हिंदीमध्ये विचारलं तरी चालेल. तुमच्या क्युरीज शेअर करणं ही माझी जबाबदारी आहे, आणि सरांनी मला जो संधी दिली आहे त्याबद्दल मी डेफिनेट आपल्या क्युरीज इथे हे करील. अँड आय एम स्पेशली थँक्स टू अगेन Professor Dr. Omkar sir for giving this opportunity to deliver the talk in front of such a eminent professors in physics and students and excellencies, and in front of the faculty members uh, of those college. The college is a very premium and the highly potential college, not only the Yavatmal in Amravati district, in whole Amravati University and in Vidarbha also. Thank you, sir. Thank you. And once again, I express my sincere gratitude toward honorable management and the principal for the same. Thank you.
Welcome and thank you, sir.
Thank you very much, sir. Any questions from student sides?
डिअर स्टुडंट, यू मे आस्क इन मराठीत पण तुम्ही विचारू शकता. थोडासा म्हणजे थोडं रिसर्च पार्ट बोललो मी, पण कसं राहते आपल्या BSc ला फार असं बेसिक क्वेश्चन, बेसिक म्हणजे खूपच बेसिक आहे. मग आता तुम्हाला नॅनो सायन्स अँड नॅनो टेक्नॉलॉजी हा 6th युनिट आहे, आय थिंक 6 सेमला, बरोबर आहे. तर त्याला ॲडव्हान्समेंट काय आहे त्याचं तुम्हाला कळलं पाहिजे, कारण येणारा सेम तुमचा आहे. म्हणून मी थोडंसं त्याला थोडं डायव्हर्ट केलं रिसर्चकडे.
Any question?
If
No
no
one
more
has
question,
any
you may
doubts.
put
Okay.
your queries in chat box. You may share directly on my WhatsApp. You may share directly on my email. You may contact with Professor Dr. Omkar sir, head of the Department of Physics. Okay. तुम्ही सरांना पण तुम्ही शेअर करू शकता, तुम्ही सरांना पण हे करू शकता, आणि मला पण तुम्ही डिस्कस करू शकता.
सर मेरा एक क्वेश्चन है.
बोलिए मैम.
सर नैनो पार्टिकल प्रिपेयर करने के लिए लो सिंथेसिस टेम्परेचर की जरूरत होती है ना?
क्या मैम?
सर नैनो पार्टिकल प्रिपेयर करने के लिए लो सिंथेसिस टेम्परेचर रिक्वायर होते हैं ना?
हाँ ठीक है ना
सर
मैम.
तो मैक्सिमम कितना टेम्परेचर तक मतलब नैनो
मैम
मटेरियल?
उसका कैसा है मैम, देखो लो सिंथेसिस नहीं, आप कैसे नैनो पार्टिकल अभी कैसे बहुत एडवांसमेंट मेथड्स है, आप इको फ्रेंडली भी सिंथेसिस कर सकते हैं. लेकिन कैसा है, सपोज हम लोग नैनो पार्टिकल सिंथेसाइज कर रहे हैं, वो जो मेथड है उसमें क्या करते हैं हम उसको जो हमारा जेल होता है उसको ड्राइड करते हैं, बराबर
हाँ,
है.
यस सर, यस सर.
ड्राइड करते हैं तो ड्राई के एट द टाइम हमारा जो टेम्परेचर होता है बहुत हाई चाहिए, अप टू 800 टू
हाँ, यस सर.
1200 डिग्री सेल्सियस. और उसके लिए जो मफल फर्नेस है वो आप यूज कर सकते हैं.
यस सर. ओके सर.
Thank
थैंक यू
you.
सर. थैंक यू सर.
Thank you, ma'am.
Thank you very much, sir, for your valuable information regarding nanoscience and nanotechnology. You have beautifully explained about nanomaterials and its classifications, various synthesis approaches, and characterization techniques. You explained what is quantum confinement, application of nanomaterials, and so on. As sir, you have said, definitely we can save electricity using LEDs. Thank you very much, sir, for sharing your knowledge. Thank you, sir. The
Thank
end
you.
part of the program is vote of thanks. So I would like to admit my thought here. A good event never ends. They take only a pause and keep us awaiting for the next. At the end of the program, I would like to call Dr. Shilpa Vidade Madam to propose vote of thanks. Over to you, Madam.
Thank you, ma'am. Good afternoon to one and all present here. It's my great privilege to propose a vote of thanks. I, on behalf of Department of Physics, Adarsh Mahavidyalay, Damangaon Railway, and on my own behalf, extend a very hearty vote of thanks to today's guest, Dr.N.R.Pawar, Assistant Professor and HOD Arts, Commerce and Science College, Maregaon, District Yavatmal, for his efforts towards nanoscience and nanotechnology. He has beautifully explained the concept of nanoscience, that is from introduction of nanoscience, formation of nanomaterials, its characterization, techniques and application in different fields such as physical, agriculture, biomedical field, pharmaceutical field and future and challenges in a nanoscience. Thank you so much, sir. I extend my sincere thanks to our mentor and president of today's program, Dr. Y.B. Gandure sir. Without his support and encouragement, this program would not be successful. I am also thankful to our Professor Dr. S.G. Onkar Sir, HOD, Department of Physics, for his enormous cooperation for the guest lecture. Well, an event like this cannot happen overnight. The wheels start rolling week ago. It requires planning, a bird eye for details. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues of Department of Physics who know their job and are result oriented. So I am thankful to Assistant Professor Mr. Thul, Assistant Professor Mr. Girish Mende, Assistant Professor Dr. Shweta Sharma, Lab Attendant Taide Kaka and Sharad Chanda for their great support and cooperation. I am also thankful to all respected faculty members of Adarsh Mahavidyalaya and students. Without their presence, this guest lecture would not have such a grace. Thank you all. Last but not the least, I would like to conclude this program by saying everything happens for a greater good. Thank you so much.
Thank you, ma'am. Thank you, sir.
Welcome, sir. Thank you, sir.
Thank you, sir.
Thank you for nice lecture.
Thank you, sir. Thank you, sir.
Thank
Thank
you
you
very
very
much.
much,
चला ओके ठीक आहे सर
sir.
चला हां
Thank you so much. You are welcome, sir. I would like to visit your lab.
शुअर सर
I
शुअर
would like to visit your lab, sir.
डेफिनेट सर
Ha.
इट विल
Lab.
बिकम प्राउड मोमेंट फॉर मी डेफिनेट सर
No doubt, sir.
थँक यू सर बाय सर गुड डे
Sir,
सर
I will send you, your certificate, or I will directly contact with you with the certificate. Huh?
शुअर सर
Ah.
नो इश्यू सर थँक्यू
एक मिनिट पवार सर तुमचे
बोला सर.
खूप 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 आभार.
धन्यवाद सर
आपण वेळ दिला. मला थोडं सर्दीने बरं नव्हतं.
हो काही हरकत नाही
तुमचं गेस्ट लेक्चर मी सगळं ऐकलेलं बरं का.
थँक्यू सर. आणि आपल्यासारख्या इमिनंट एक्सपर्ट समोर मी गेस्ट लेक्चर दिला आणि तुम्ही ते अप्रिशिएट केलं रिअली ते माझ्यासाठी खूप चांगलं आहे सर.
अतिशय छान.
हा
खूपच छान एक्सप्लेन केलेलं.
थँक्यू
आणि फिजिक्स डिपार्टमेंटचे सुद्धा खूप खूप आभार.
धन्यवाद सर.
डॉक्टर ओंकार सर, थूल सर, विधेळे मॅडम, मेंढे सर, डॉक्टर शर्मा मॅडम, छान प्रोग्राम ऑर्गनाईज केला. आणि भविष्यामध्ये आपण नॅनो सायन्स आणि नॅनो टेक्नॉलॉजीवर एखादी कॉन्फरन्स घेऊया. आपलं नक्की
Sure, sir.
मार्गदर्शन लावेल सर. थँक्यू
बिलकुल सर. थँक्यू सर.
थँक्यू थँक्यू.
We are
आणि
thankful, sir.
सरांचे आम्हाला नेहमी मार्गदर्शन असतात सर. ते आमचे गुरु आहे आणि आमच्यासाठी आदर्श आहेत ते.
Ah.
नाही
बिलकुल सर.
हा तुमचा मोठेपणा झाला सर.
नाही नाही नाही.
Principal, sir, we are proud of you, sir, for your cooperation, relation, huh? and
थँक्यू.
encouragement. Huh? We are so
ओंकार
much
सर
thankful to you, sir.
ओंकार सरांनी
Proud
या
of you.
वयामध्ये रिसर्च केलेलं
राईट.
आणि ते त्यांचं फार अप्रिसिएशन आहे बरं का महाविद्यालयासाठी. येस
माझं वयच कुठं आहे, सर?
शुअर सर. राईट.
पुन्हा धन्यवाद सर. भेटू
थँक्यू
आपण
सर.
एकदा.
थँक्यू सर. बाय सर. बाय सर. गुड डे
ओके
सर. बाय.
थँक्यू.
Thank you, sir.
इथून लेफ्ट असं करायचं होतं.
The program is over. Everyone can left now.